Today we're going to talk about how to graph a quadratic equation in factored form. So factored form means that we've rewritten the quadratic so that there's multiplication between every term. So there's no plus one at the end, everything is multiplied. So let's remember how we solve a quadratic equation that's set equal to 0 by factoring. So the first thing we need to do is determine what goes inside the brackets. We could either use a trick like PSI or just look at it and do guess and check. So in PSI we look for two numbers that are products that multiply to 2 and that give us a sum of 3. What are the numbers that multiply to 2 and add to 3 that are a product of 2 and a sum of 3? 2 and 1. So that tells us what to put inside the brackets, but we should always be careful and do a quick check. It's easy to make a slip up and say the wrong thing. So we'll multiply the first two together, that gives us x squared, check. Our last two together, that gives us the 2, that's correct. Now let's think about those x terms, those inside terms. X times 1 gives us 1x, good, hopefully. And the middle one's 2x. 2x plus 1x gives us a total of 3x. So if we were to expand this all out and collect it, we'd get 3x. That's what we wanted in the middle. So this is fully factored. Now when two things multiply to equal 0, that means that one of them has to equal 0. Like if I say 2 times something equals 0, what's the only thing we can multiply 2 by to get 0? Well, that's 0. So either x plus 2 is equal to 0 or x plus 1 is equal to 0. So x is equal to negative 2 or x is equal to negative 1. Those are our solutions to this equation. It's important that you have that factoring and solving skill to be able to do this graphing today. So how does that relate to the graph? If we have this equation in factored form, we should be able to find the x-intercepts. The x-intercepts are when we set y equal to 0. We saw in our last equation we set y equal to 0 and we solve for x. Those are our x-intercepts. This is already factored for us, so it's pretty easy to find the x-intercepts. We would set y equal to 0, and our x-intercepts are 1 and negative 3. What about the vertex? Where does the vertex go? Well, that's a little bit more tricky. Let's just start by graphing our x-intercepts and then figure out the vertex. A quick scale, indicate x and y. Okay, so we have an x-intercept at 1 and an x-intercept at 3. Where would the vertex be? How does the vertex relate to the x-intercepts? Well, the graph looks something like this. It may not be exactly like that, but the vertex is always right in the middle because we have an axis of symmetry. The vertex is somewhere like this. The important thing is that the x value is definitely halfway between negative 3 and positive 1. It's pretty easy on the graph here to see that the x-coordinate of the vertex would definitely be negative 1. But in general, what do? So in general, the x-coordinate of the vertex is halfway between We've seen this before, something in the middle. We saw it with midpoint. When we're looking for something in the middle, what do? We do the average. So it's halfway between those x-intercepts, so we need to do the average of them. Add them together and divide by 2. So the x-coordinate of the vertex is negative 3 plus 1 gives us negative 2 over 2, which gives us negative 1. Great. Now how do we find the y-coordinate? of the vertex. That's important. It was easy to place the x-coordinate, but we need to know how far down that vertex goes. We know the x-coordinate, and we have the equation. We sub it in. So y is equal to 0.5. Sub in the x-coordinate. Oops, I missed the negative here. -1 minus 1, -1 plus 3 is equal to 1/2 of -2 times +2. So -2 times +2 is 4. -4 and half of that is -2. Okay, so let's redraw this sketch better. So that vertex is at -1, -2, and then it has to go through these x-intercepts. Now, I didn't quite get this graph so perfect. I know that there's a vertical compression by a factor of 0.5 from what we know about vertex form, because that a value would work out. So that can help me figure out how to graph that point on either side of the vertex. Now we have the graph. So here's another question, and we need to factor it. First, find the x-intercepts, and then find the vertex. So to factor it, we set it equal to 0, and then try to break it up to get the factors. So 2x, we could have 2x and x, or we could have x and then 2x. Let's try it this way. We could try the 3 first and then the 1, but notice that when we expand this, we get 3 plus 2x is going to give us 5x, so that's not big enough. We need it to be bigger. If we multiply those numbers together, we can get something a bit bigger. Now if we do a check, we'd have a 1, and a 6x gives us 7x, so that checks out. And we can check our first multiplication. 2x times x is 2x squared, good. 1 times 3 is 3, good. Everything works out. So now we can set each factor equal to 0. Don't really need a bracket there. Or x plus 3 is equal to 0. I'm going to move the 1 over, divide both sides by 2, so x is equal to -1/2. And here x is equal to -3. So we have our two x-intercepts. Let's put them on the graph. It's mostly negative values here, so -1/2. Oh, sorry, I just want -1. -2, -3. Okay, so we have one x-intercept at -1/2, and another x-intercept at 3. Where's the vertex in relation to those x-intercepts? It has to be right in the middle. It's a little bit tricky to look at this right now and figure out where the middle is. They're 2.5 apart, so the middle is like 1.25 away from the 3. It's a little tricky, but we could double check and get an exact number. So to find the x-coordinate of the vertex, we want x is equal to, we're going to add together our x-intercepts and divide by 2. So we have, I'm going to do decimals because we're graphing. I'm not a big fan of decimals in general, but when we're graphing it'll make things easier to see. So 3.5, we want half of that, so 1.75 negative. I think that works. Yep. Okay, and then let's find the y-coordinate of the vertex. So we just sub that in and we can get the y-coordinate of the vertex. So 2 times -1.75 squared plus 7 negative 1.75 plus 3. Okay, let's try that out in the calculator. 1.75, it's going to be squared, so it doesn't matter that it about the negative. Whoops, I did square root. Okay, I've got to try that again. 1.75 squared. Still on square root. Okay, I don't know why my calculator is not functioning. I guess this is not how they say square root, this is how they say square. This number makes sense because our number is pretty close to 2. 2 times 2 is 4. And I know 1 1/2 and 1 1/2 is like 2.25 or something like that. So this is a logical number, so we'll keep going. That's multiplied by 2. And then we have to add 7 times 1.75 negative. And then there's still a plus 3. Okay, so we've got negative 3 1/8. Negative negative 3.125, 3 1/8. Okay, so our x-coordinate of our vertex, let's just write our vertex here. Negative 1.75, negative 3.125. Now remember, logically, the vertex is halfway between, so that makes sense. We could do our axis of symmetry. It might make it easier to find that y-coordinate nicely. And then the y-coordinate 3 and a little bit. And this is our graph. It looks like it has a vertical stretch by a factor of 2, so it's a little bit more steep than the usual. And that's basically what it looks like. You can also look at it logically. Our leading coefficient here, our first term is positive, so we know it opens up. That makes sense. Where our 3 points were located, it opens up. If the vertex was somewhere else and it made it open down, then we'd know that we had made a mistake. So these are our graphing steps. Find vertex form, so find factored form, which means you need to factor. When you have your two x-intercepts, those solutions, add them and divide by 2. Take the x-coordinate of the vertex and sub it in to get the y-coordinate of the vertex. Now let's find the equation given the graph. So we need to identify some of the important values. So here we have an x-intercept of 0.5 and an x-intercept of 2. The form of the equation looks like this: x minus s, x minus t, where s and t are the x-intercepts. So that means we have a x minus our first x-intercept of 0.5 and x minus our second intercept of 2. We would like to find a. How we do this is we sub in a point and then solve for a. Just like when you were learning about lines, you often found the y-intercept by subbing in a point and solving for b. Very similar. So what's a nice point to look at here? There's no perfect, beautiful ones that I can see. Maybe this is our best one. So this point is 1, negative 2.5. If you mix up subbing in the coordinates sometimes, maybe write x and y up above to make sure that you plug them into the right place. So I subbed in the y value, now I'm subbing in the x value. And let's get all of our numbers here brought together. So 1 minus a half is a half times -1. Okay, so we have a very simple linear equation here to solve now. So we can divide both sides by -0.5. How many times does 0.5 go into 2.5? That's like asking how many times does 5 go into 25. So that's 5 times. Negative by a negative is a positive. So a is equal to 5. Now we can write the equation. Y is equal to, a is equal to 5. And let's put our x-intercepts back in. Now there's a little trick here. Usually when it's a fractional value for the x-intercept, we rewrite that factor. So right now it has x minus 0.5. Now imagine our solving steps when we're trying to figure out what the x-intercept is. If we set that equal to 0, this would be the exact same if I wrote it as a fraction. It would also be the exact same if I multiply everything by 2 and get rid of that 2 in the fraction. So I'm going to multiply. So I have 2x minus 2 over 2 is equal to 0 times 2. So now I have 2x minus 1 is equal to 0. So because this is equal to 0, so when we have a decimal or fraction, we often rewrite it so that it's a whole number and then it has a coefficient on the x term. It's completely equal to the line above, but this is our preferred form. Okay, next example. Find the equation. So I can see my x-intercepts are right here. So I can get those in the equation right away. The equation is ax minus s times x minus t, where s and t are the x-intercepts. X minus 0 and x minus -2. So we have a little bit of simplifying we can do here. How do we find a? Sub in what you know, solve for what you don't know. Got a nice clear point here with the vertex, so let's use that. Again, if you're going to make silly mistakes with x and y's, try just putting x and y up above. Usually you'll have less of a chance of making a silly mistake. So I subbed in my value for y and my value for x. So I have -1 times +1. So 2 is equal to -1. I'll divide both sides by -1. So a is equal to -2. So my final equation, y is equal to -2 x. Now I could go back to this line here, but there was some simplification done. So I'm going to go back to this line and sub things in. So just an x plus 2. We also usually don't put brackets around when it's just a factor of x. We usually would write it like this, -2x times x plus 2. And this is our preferred way of writing it in vertex form. Oh, I keep saying vertex form because the whole last chapter is vertex form. Factored form. This is in factored form because everything's multiplying. It's factored. Okay, so keynotes. When we want to graph a quadratic equation using factoring, we can factor first to find the x-intercepts. Once we found the x-intercepts, it'll be in a form like this, x minus s, x minus t, and it'll be the opposite sign you can see on the x-intercepts because you set it equal to 0 and solve, so you move the s over, you move the t over, the sign becomes the opposite. The x-coordinate of the vertex is equal to s plus t divided by 2. That's the axis of symmetry. That's right in the middle of the x-intercepts. To get the y-coordinate, well, sub in the x-coordinate and you get the y-coordinate. Draw the parabola through these 3 points, and you can check by subbing in a point. Now, if you're given the graph and you're asked to find the equation, fill in what you know into the equation. So we're doing factored form here. You should be able to see the x-intercepts add them in, and then find another point on the graph and sub it in for x and y, and then you'll have numbers everywhere, and you'll be able to solve for a. Remember, one equation, one unknown, solvable. Your homework is page 287, number 1 to 8. If you have any questions on homework, you could email it to me, take a picture and email it. Good luck!